Okay, last subtopic for this chapter, diffraction grating, which have multiple slits. In this subtopic, you have to be able to explain the formation of diffraction with the aid of a diagram, and lastly, apply this formula in any sorts of problems. Okay, so for bright fringe, m is going to be equal to 0 when it is at 0th order max. Untuk first bright or first order max, m is going to be equal to 1. Capital N here is the number of slits per unit length. Okay, so diffraction grating is defined as a device with a large number of equally spaced parallel slits, as we can see here. It can be made by ruling very fine parallel lines on glass or metal by a very precise machine. The untouched spaces between the lines serve as slit, which is those ones shown here. So the light passes through the slit because it is transparent, and this slit separation here is given by this equation here. Okay, so grating may operate in reflection or transmission. So it is used. There are two types of diffraction grating. The first one is transmission grating, which is used in CD or DVD. Why is it DCD? It should be DVD. CD or DVD. And then usual diffraction grating, muslin cloth, and then for reflection grating, also CD and DVD lah. Okay, so it is used in spectrometer to determine the wavelength of light and study spectra. Okay, so the formation of diffraction grating pattern. When a monochromatic light is incident on the diffraction grating, which is this one shown here, each slit acts as a secondary source. So this is a source which emit large number of secondary wavelets. Okay, so these diffracted secondary wavelets then interfere with one another. So as the light fall on the distant screen, it forms central bright fringe. Okay, so M gonna be equal to 0 lah untuk central bright fringe, and higher order bright fringe, which start at 1, 2, 3. Okay, so these bright fringe are due to constructive interference, also known as maxima. Okay, so diffraction pattern, this is what you will see for diffraction pattern from a grating lah. So the theta here is measured from the horizontal, and then each of these rays travels a different distance to a common point on the screen far away lah. So as seen in this figure here, each ray travels a distance d sine theta different from that of its neighbor. So semua ni berbeza. So if distance equals to an integral number of wavelengths, the rays would all arrive in phase, and constructive interference is obtained, which is this one shown here. This is the bright fringe lah. Okay, so the formula for diffraction grating, in general, we know that the angle associated with, it should be M sudah bani, dia tukar. M order maxima is given by this equation here. So the highest order that can be observed should not exceed 90 degree lah. Okay, so it should be less than 90 degree. So the order number is should be less than the d over lambda, which is the slit separation over the wavelength lah. Okay, so the number of order can be seen with depend on the grating spacing and the wavelength. So if we look at here, the number of order can be obtained is 3. So di sini 1, 2, 3, ada 3 order number kan. So the number of maximum can be seen on screen is calculated using this formula here, 2m plus 1. Okay, kenapa plus 1? Sebab kita perlu consider dia punya central maximum. So figure out how many number of maximum can be seen on this image here and write it down here before you submit your notes. So the longer the wavelength, the less number of maximum can be seen on screen lah. Okay, so diffraction of white light. When white light, which is for example sunlight, falls on the grating, a rainbow of colors is produced at each principal maximum lah. So kamu akan nampak rainbow on either side of the central fringe. So the central maximum, however, it will be white because all the colors would overlap here. Sorry. So this is because the white light contains wavelengths between violet and red lah. So different colors have different wavelengths, so different colors will be reinforced at different angles, hence the formation of rainbows. Okay, so these are the diffraction pattern of double slit, single slit, diffraction grating, and the one yang using monochromatic light. This one is using white light lah. So ada rainbow sebab dia ada wavelengths between violet and red. So that's why dia ada nampak different sorts of colors there. Okay, so let's look at an example. A monochromatic light of unknown wavelength falls normally on the diffraction grating. The diffraction grating has 3000 lines per centimeter. So that is n 3000 per centimeter. If the angular separation between the first order maxima is 35 degree, calculate the wavelength of the light. Okay, so what? The angular separation between the first order maxima. So if we were to draw that, this is first order max. Dia cakap between the first order max. So this is first order max also lah. Okay, so the angle here is 35 degree. Lepas tu dia minta the wavelength of the light. So we can use the formula d sine theta m equal to m lambda. So what is the value of m? M is going to be equal to 1 lah sebab dia cakap first order. Kalau dia cakap zeroth order ataupun central, barulah kita guna 0. Tapi sekarang ni dia minta first order. So m is equal to 1. Okay, so the theta here, theta is the angle associated with the order maxima. So dia bukan between the two of them. Macam bukan di sini. This is not theta. Theta is just, it consider only one side of it. Okay, so they don't look at both sides. Okay, so maksudnya kita punya theta ni sepatutnya theta m ni sepatutnya 35 divide by 2 lah, which is theta 1 35 divided by 2 is 17.5 degree. Okay, barulah substitute into this formula here. So d is, we have to find d. So how do you find d? This is d equal to 1 over n, which gives us 3.33 times 10 negative 6 meter. Okay, so substitute lah into the formula here, which is 3.33 negative 6 sine 17.5 degree, okay, equal to lambda. So lambda is equal to 1 times 10 negative 6 meter. Right, so that's how you find the angular separation between the first, find the wavelength of the light. Right. Last example, example 13. We have a monochromatic light from a helium neon laser. That is the wavelength incident normally on a diffraction grating containing 6000 lines per centimeter. So this is the value of n. Find the angle at which the second order is observed. So second order, you minta second order. So we are going to do the second order lah. Okay, so for second order, m is going to be equal to 2. So the formula is again d sine theta m lambda. First we have to find d. So d is just 1 over n. So 1 over 6000 give you 1.67. Okay. Wait. 1 over 6000 is 1.667 times 10 negative 4 meter. Kan? D is equal to 1 over n, which is given here. Okay, so why did this one use 1 centi? Okay, never mind. Okay, so that is your grating space. This is D. So from here, we are looking for theta. Okay, so theta 2 lambda. I am rearranging this over D, so shift sign. Kan? Bawah. Okay, so shift sign 2 lambda is 632.8 nano divided by 1.667 negative 4. So the angle for the second order is shift sign 2 times 632.8 times negative 9. This is 1.667 negative 4. So the angle is 0.43. Wait. Why is it... Okay. Shift sign for 0.43. 0.435 degree. But shouldn't it be a greater value? Okay. Let me just check. Oh, okay, patutlah salah. Okay. So I did something wrongly here. It's centimeter pula. Okay. Ni adalah centimeter. Kan? Patutlah. 1/6,000. So it should have been 1 point... Okay, wait. Okay, so this one just now 1.667 times 10 negative 4 centimeter. Tapi sekarang kita perlu consider dia punya centi. Change it to meter, so it's gonna be times 10 negative 6 meter. Okay, so maksudnya di sini negatif 6. So jawapan di sini sepatutnya 43.5 degree lah. Sepatutnya. Let me just check. Shift sign that 49 point something. 49.27 degree. Okay, so 49.39 degree jawapan dia. Okay, so that is the solution. I'm just looking at this one. Okay, but yeah. So that is the angle at which the second order is observed. Next, how many maximal lines can be observed? That one is just x equal to 2m plus 1. So how many maximal lines can be observed? So this is a second order, 2 plus 1. So 4 plus 1 is 5. So we can just write 5 lines. Okay, so that is the solution for example 13, and that is all for subtopic number 9 and the whole chapter 7.